Hi, this is Raf Alvarado. I'm the Program Director of the Residential Master's Degree in Data Science at UVA in the School of Data Science. And I'd like to tell you what distinguishes our Master's Degree in Data Science from other programs. Yeah, so I think what distinguishes UVA's Master's Degree in Data Science is that it's built on a set of principles that go beyond simply providing students with the right information. Sometimes education is conceived of as a kind of information transfer. You listen to Elon Musk and he will tell you that universities are not necessary because you can just get everything online. We beg to differ. There is actually a bunch of stuff that elements and dimensions of education that are crucial to the success of the process, and we really cultivate those. So the first of these I would point out is that our program is cohort based. And what that means is that every class that comes in is part of a group that works together and takes classes together and socializes together very frequently and experiences the whole thing together. Classes are not separated out. Students are not tracked into smaller groups and that sort of thing. And so it's really a big part of the experience, and students almost universally reflect on this as very positive. The second thing is, and related to this, is that the program is accelerated. It all happens in an 11-month period. It's got an intense kind of a hothouse quality to it. Students begin in the middle of the summer, taking a boot camp. Then they're immediately introduced into the core subjects of statistics and computer science, the foundational elements that allow them to then go into the machine learning, Bayesian machine learning, the ethics classes, and the deep learning classes, and so forth that they take in the rest of the year. One of the other things that distinguishes our program, though, I think what really sets it apart is that it's really the curriculum is based on a principled understanding of what data science is. It's not simply, as I mentioned earlier, just the integration of computer science and statistics. We actually distinguish 5 areas of data science, each of which are super important and each of which are connected to the others. The first is the area of value. All data science, all work in this field begins with some notion of what is important about what you're doing, some value proposition, some strategic understanding of data, and also an ethical understanding of data. Those two things are related. They have to do with what the value of what you're doing involves. And we take that very seriously. We require a course in ethics, but we also have a course, a capstone course that integrates all of your learning that forces you to think of the value proposition of what you're doing and to help work with the client to come up with that value proposition as well. The second area is systems, and what that involves is the hardware and software required to do data science in the modern world, where you have big data and you have sensor data coming in and transactional data and social media data and huge databases. We want to introduce you into some of these technologies: Python, R, AWS, Azure, PySpark, relational databases, NoSQL databases, and so forth. That's a huge technology element that supports everything. The third area is analytics, and this is what a lot of people sometimes think data science is. It is the area of statistics and computer science, where computer science is understood as a kind of mathematics, a kind of discrete mathematics, simulations, operations research, and a host of other mathematical approaches to working with data. And then finally, there is the area of design, which has to do with how data is represented before it becomes analyzed so that it can be processed. We think of data as a form of representation, as a medium, and that there's an important element of design that happens when you take data from the world, you capture it, you acquire it, and you want it to be faithful to what it is representing in the world. That is a crucial process, because if the data is not faithful to what you're representing, and if it's not accurately structured, it's garbage in and garbage out. Complementary to that is the ability to visualize the results of some of these complex analytical processes that we apply to data. You can create something extremely sophisticated, but if no one understands what it means or says, then it's not very useful. And this is where visualization comes in, but also a host of other methods to convey the complexity of a data science solution to someone who can make use of it and actually derive value from it. I said that was the last one. There is another, which is practice, and this is putting it all together. Those 4 pieces that I just mentioned don't stand separately. They all are integrated when you actually try to solve a problem in the real world, say in medicine or in finance or in education. All of these things are brought together, and there is the integrative practice of data science that we teach as well, primarily through our capstone program. We like to say that data science is a team sport, and this is where that game is played, and where you form a team and actually solve a real world problem using all of the tools that you have learned in your classes. Yeah, so another feature of our program is that we believe that ethics is not simply one part among many in the model of data science that we've developed. We think that ethics cross-cuts everything, and that should be integrated into all of our courses. So for example, a course on deep learning and neural networks, the idea of the opacity of the models that a neural network will produce is something that we want to teach in that class. The idea of interpretable AI and explainable AI, which is something that is of great interest to ethicists and policymakers, is something we think should be taught in those courses, but also directly in the courses where they arise. And we feel like this cross-cuts all the courses. In fact, we've done an exercise with all of our faculty where we go through every syllabus item that's taught and try to map an ethical question or issue associated with it. And then we find those where we think it might be profitable to discuss that issue in that context. So it's really important to us to integrate ethics throughout the program and not to see it as a kind of a bolt-on thing, a seal of approval that we're doing something good. I should also say that our ethical orientation is part of our capstone selection process. A lot of the capstone projects that we choose are for the social good. Some may have to deal with racial disparities in various areas. A lot of them have to do with medicine. We really want to make sure that data science, that you're learning data science for the social good, in addition to learning the fundamentals of the field. So I invite you to apply to our program, learn more about it. There's a lot of information that we provide on our website. We also, I would like to emphasize, accept people from a wide variety of backgrounds. It's by no means a STEM-only field for us. Of course, you need to meet the basic STEM requirements, learning a computer programming language, knowing statistics and probability, linear algebra, and so forth. But we have gotten people from a variety of fields, from the humanities. We've had historians, we've had doctors, we've had engineers, software engineers, we've had statisticians. By no means does it favor one or the other group, because each one of those backgrounds actually has a strength in our model of data science. And when these various candidates come together in the class, in the cohort, they complement each other. And this is one of the great things about the program, is by having this diversity of our class and having a cohort model and an integrative understanding of data science that's all put together in the capstone experience. All this diversity complements and produces some pretty interesting results.